for what you're going to create today. The intent behind the hackathon is to launch as many incredible agent projects as we can. And so we take inspiration from Andre and the speakers to come.
Thanks, Jenny. Test. Okay, cool. Hi. Okay, hi everyone. The microphone is working, right? Okay, cool. So I was recruited to say some words of inspiration on the topic of AI agents. So I actually wanted to begin with a story. I think like AI agents are near and dear to my heart to some extent because this is a story from very early OpenAI, back when it was like maybe a dozen people. And this was 2016 or so, and the zeitgeist of the day actually were RL agents. And so everyone was really interested in building agents, but very much at the time it was in the context of games primarily. So it was the height of excitement around Atari and all the game playing and so on. And so my project at OpenAI was trying to focus the RL agents not on games, like Montezuma's Revenge and so on, but on using computers, using keyboard and mouse. And so I wanted to make them useful, I wanted to make them do lots of tasks, and this project was called World of Bits. And I worked on it together with Tim Shih and Jim Fan. They're somewhere here, I think I saw them. And so the three of us ended up publishing a paper. It's not a super amazing paper, because basically at the time, all you had as a hammer was reinforcement learning. And so we had these very simple web pages, and we were trying to like order a flight or order something to eat in very simple web pages. And we were mashing buttons and mouse clicks and so on, and we were trying to like stumble our way into higher rewards. And obviously it didn't work. So the technology was just not ready, and that was not the right thing to work on at the time. And so it turns out that the right thing to do at the time was actually to forget about AI agents altogether and start building language models. And then language models, now we're back here 5 years later. I got distracted with self-driving for a bit there. But it looks like AI agents are cool again. But the toolkit has changed completely. And so the way you would approach these problems today is completely different. In fact, all of you are working on AI agents, but you're not using any reinforcement learning, probably. And so that's so crazy. And I don't think we would have anticipated it at the time. It's just the way this played out is very interesting. So I want to spend a bit of time on like, okay, what is causing all this hype? I think obviously the reason that all of you are interested in this topic is that it's, I think, very obvious to a lot of people that AGI will take the form factor of some kind of an AI agent. And it's not just going to be a single agent, maybe there's going to be many agents. Maybe they're going to be in organizations or civilizations of digital entities. And I think it's just extremely inspiring to sort of like think through. It's kind of crazy. I also want to pour some water on it too, though. I think there is a large class of problems that I think are very easy to imagine, very easy to build demos for, but are actually extremely hard to make products out of. And I think many things fall into this category. I would say self-driving is an example of it, actually. Self-driving is very easy to imagine, very easy to build a demo of a car driving around the block, but making it into a product takes a decade. And the same is true, I think, for example, VR, very easy to imagine, build demos, but getting it to work, again, takes a decade. And I think agents are kind of like that as well. Very easy to imagine, get excited about, build demos of, but I think if you're in it, you should be in it for a decade and actually make it work. One other thing I wanted to say is that I think it's kind of interesting to go back to neuroscience now and take inspiration from it again in some ways. I think this was true in the early days of deep learning, but it's now true also again for AI agents. So it's been kind of interesting for me to think about sort of all the equivalents. So in particular, I think a lot of us, when it's clear that a language model is a part of a solution, but how do you build an entire digital entity that has all of the cognitive tools that humans have? So obviously we all think we need some kind of a potentially system too, to actually like plan ahead and think through and reflect on what we're doing. And there's a lot more that you can take inspiration from. So for example, the hippocampus is important. What is the equivalent of the hippocampus for AI agents? Well, it's somehow like recording memory traces and maybe indexing them using embeddings and retrieving from them, something like that. So maybe that's kind of like the retrieval kind of thing in the brain. We, I think, understand how to build visual auditory cortex roughly, but there's many still things that are like, what are the equivalents of them in AI agents? What is the basal ganglia doing? What does it look like in an AI agent? What is the thalamus doing? The thalamus sort of integrates all this information together. It's kind of like potentially the seat of consciousness, and it's got this very interesting neural circuit where if you think of your brain as sort of like multiple entities fighting for the microphone as to like what you're going to do, the thalamus is probably where that happens. It's kind of interesting. So I actually brought a book that I liked on neuroscience. It's called Brain and Behavior by David Eagleman. And I find this very interesting and inspirational, so I'll leave it here if you'd like to go through it and page through it. And I just think that there's some interesting inspiration to, again, draw from neuroscience, just like we did early on with respect to how we design an individual neuron. We can do that again today. Maybe. Finally, I wanted to end with some words of inspiration. What's interesting and not obvious is that you guys building AI agents are actually at the forefront of capability of AI agents today. And all the big labs, like LLM labs of OpenAI and DeepMind and so on, I suspect are not at the edge of the capability. You are at the forefront of it. So OpenAI, for example, is very good at training massive transformer language models. So as an example, one way to put it is, if a paper comes out that proposes some different way of training a transformer, the internal Slack at OpenAI is something along the lines of, oh yeah, someone tried that 2.5 years ago, and here's what happened, and here's why it didn't work. And it's very well understood and very well mapped out. But when a new agent paper comes out, we're all interested, and we look at it, and we're like, oh, that's really cool, that's novel. And that's because the team didn't have like 5 years to spend on it, and it's competing now with all of you, and the entrepreneurs and hackers and so on. It's really hard to do. So yeah, I think it's really inspiring that you are at the edge of capability and on something that is obviously very important and transformational. And so with those words, I think I'm eager to see what you guys build.
So yeah, my friend Switz actually asked me a question a week ago about why I run hackathons, among other things. And yeah, I guess Mr. I think Marco's here, Andre's here. For the last 9 months, we've been running these hackathons, and we try to bring incredible people. So for example, like, we got Robin from the original German Stable Diffusion, the real Stable Diffusion, to hack with us, right? And there's something beautiful about hackathons. So first of all, it's permission. All of us have jobs, but today we're allowed to do whatever we want. It's unbounded creativity. We can come up with a project and ship it by the end of the night, and we don't have to care whether or not our employer approves or disapproves. And we work with people who are not necessarily at our company, but who might just be friends that we like. And this is actually how I think work should be done. But crazily, this is not the norm. If I'm honest, the hackathon style of working, where you have an intense 6 or 7 hour burst of productive energy, and you code some new chain into existence, and you launch it on a website, and suddenly you feel the potency of being a software developer who can transform an idea into reality in moments. It's a kind of state of mind where it feels like your thoughts and your creative ideas are so close to becoming someone else's lived experience. There's a kind of power that's special about the hackathon that you don't get in the sort of standard launch process at Google. Yeah, I guess there's a body of collective creativity. So you're currently in a room, with 30 people, but now with 150 people. All of you could come up with an idea, seize a few team members, and build a new body of friendships. And those friendships can turn into projects that either become companies or are transformative in some other way. And typically, in an org job, you're trapped with the exact same team, you work with the same people, working on the same things all the time. And all of the learnings from people's software development styles are not available to you. And so I guess finally, there's a sense that when you're working, you should try to align what you're doing as much as you can with the way that you enjoy things emotionally. And I think the hackathon aesthetic is actually much more emotionally available and aligned with the spirit of how people love the program, where they just go into a cave for 3 days straight and emerge with some glorious project that they just imagined, than the typical sort of 9 to 5. And so, in part, it's an expression of an idea. So yeah, I guess with all of that in mind, do try to engage with this hackathon and the hackathon ethos and spirit of becoming quick friends with your collaborators and bursting some incredible project into existence. The one requirement for being in this room is that you are going to ship by the end of the night. So produce code, and produce code that everyone can be inspired by and that you can present and be proud of. And in this sort of single moment, we will collectively be able to burst possibly 50, maybe 60 new agent projects into existence. And they don't all have to become companies, but the reality is that, on Twitter on any given day, maybe you see 2 or 3 projects that you're inspired by. It's plausible that in a single day, this community can produce a month's worth of inspiration through a hectic 7-hour experience of a hackathon. And that the mates that you make over the course of this can be friends, and you'll do projects together for a long, long time. And then I guess finally a comment on agents. So basically, why the Agent Hackathon? It's kind of become clear that there's tremendous potential in the use of large language models for control to a point where you can imagine the modern corporation being replaced by a hive of interacting agents, all of whom have access to every aspect of the company's processes and existence, and where the humans are merely managing the body of agents and filling in the gaps with human labor where necessary. But those gaps will continually shrink as entrepreneurial hackers like you come up with new ways in order to basically plug in automation. And so, on some level, I feel like we finally entered the true general paradigm, the AGI paradigm, where we were working on narrow models, on language models, on image models. But now with tools, it feels like every practical part of the economy that is attached to knowledge work can be executed on by an AI agent. And so everyone who's had the AGI dream feels like the agentic AI paradigm is likely to fulfill. So with that, good luck on fulfilling the dreams of a generation and experiencing your fellow hackers in an amazing way. Thank you. And so, Harrison, give me a quick talk on introductions.
Yeah, absolutely. Thanks for having me. Thanks everyone for being here. My name is Harrison, co-founder and CEO of LangChain, which is a framework for building LLM applications. We started before agents was even a term, I think, and so we definitely didn't have the concept of agents when we started, to be honest. But I think a big part of LangChain has and always will be connecting language models to other sources of data and computation. And so a lot of the tools that we've built are very useful for connecting language models to tools to help them decide what to do and to connect them to data like memory. And so when you add all that up, it starts to look pretty agent-like. And so for the few minutes that I'm going to talk today, I actually don't want to talk too much about LangChain, but want to talk in general about just a few tips and tricks that we've discovered or we think are helpful when building agents, whether you're using LangChain or not. So just running through a few quick ones. One, and also these will be very specific for like tool usage and how to get agents to use tools. I think there's another big component of agents, which is the memory aspect that Andre talked a little bit about. There's a really good paper that came out recently, the Generative Agents paper, by some people at Stanford, that uses reflection to kind of improve memory. I would encourage you guys to check it out. Most of these are focused on tool usage as opposed to memory, but both of those are important. So around tool usage, number one tip that I would have is basically just use OpenAI functions. They're really good. A lot of tool usage is deciding what to do and then outputting some structured representation of how to do that, and that's exactly what OpenAI functions are designed to do. Number two, the function descriptions are basically a prompt. The more information you put in there about like what the tool should do and when it should be used, the better the language model will know how to do that. Number three, I would say, is really, and this gets into something that Andre also touched on, which is I don't think there's going to be, AGI will look like a bunch of small agents, basically, each kind of communicating and talking to each other. And so I think the responsibility of the agent is going to be more narrow than kind of broad. And so number three is basically customize your agents and make them kind of like specific for specific domains. And so that can come in two flavors. And so if you're using a framework to build agents, whether it's Otter GPT or LangChain or anything else out there, I'd encourage you to do that. And the two main things that I see as a way of doing that are one, kind of like customizing the prompts. So instructions really matter. If you want an agent to be really good at doing data science, it's still silly, but telling it it's an expert data scientist helps. And then number two, tools matter. And so you need to be able to give agents the correct tools that they need to be able to use. And so one of the things that we have in LangChain is a collection of tools with a bunch of different focuses in mind. So we have this concept of a toolkit, which is roughly like 3 to 5 tools really focused at accomplishing a specific task. And I think when we see agents or agent-like systems that are successful and reliable, they are really focused with about 3 to 5 tools really focused at a specific task. Another thing chains, agents, LLMs can be tools themselves. So you can stack a bunch of these kind of agents together to accomplish a more broad task with each of them, kind of like routing or deciding which sub-agent to call, and then each one being a bit more specific at the bottom. Number 7, this is something we added actually just a few minutes ago, is functions can kind of start to be expensive, especially as you start to pass in a bunch of them to the prompt, and you're iterating. We added caching for chat models in LangChain like 10 minutes ago, so I would encourage people to try that. I did that instead of preparing any good slides, so I apologize about that. But I would encourage you guys to, if you want to save money, check that out. And number 8 is just 3 question marks, because I think we're really in the day 1 or day 0 of an exciting new era. As Andre said, this is kind of like this is the place to be. So all these tips and tricks could be completely useless, and so really just try to do whatever works and build fun stuff. That's it.
So I remember watching Harrison hacking on the agents part of LangChain back in January. So a lot of OG credit for being pre-chair to that, because I think GPT-4 unlocked a lot of this stuff, but you've already laid those out there pretty well. Okay, so I guess Div, let's talk about Montian. Div, where you at?
Yes.
And Switz, you're on deck.
Yeah. Are we doing slides?
We can do slides, yeah.
Sure.
And initiating the idea for the hackathon. So very excited for everyone here to be building agents and application cloud. What we'll be doing for the hackathon is giving access to Multion as a beta that you can sort of take use for taking internet actions on different websites. You can also do online purchases if you want. So if you want to order something on DoorDash, book a flight, or send messages on LinkedIn, Gmail, whatever. So we support like a lot of the services, and you will be able to use that API to sort of work with them. And I will show you what the overall idea is. So this is Multion, which has got a new logo. And the idea is you want to build your personal agents, so we want everyone to have their own AI that they can use for a lot of their different things in daily life. Cool. I'm not sure if people have seen this demo, but I can just go over it. So we booked a flight using Multion, where we went to United and did the whole flow. Let's see. Hopefully we'll load. Yeah, but you can also skip this otherwise, and people can find it online. Let me just try.
Maybe someone can turn off the light. I think it's further back, the right side. Behind you, yeah.
Very nice. Yeah, so here I introduce control in the browser, and we can browse the whole screen. I've given it some preferences, okay, like I want a United flight with economy and no seats. And I've also given some guidance, like, okay, like if you don't find the next button or continue button, maybe like look down and scroll the page a bit. And just so that helps. also select a seat. Oh yeah. So yeah, so it's pretty cool. You can do a lot of things. Thanks.
Was this a real butterfly?
Yes,
Oh, so you paid for it? You paid for
I paid for it. Then I actually call them and cancel it. I will also say I'm used to having random DoorDash orders show at my place at this point, and people might have seen a lot of random AI tweets that just show up on my Twitter. So yeah. So what our mission is, in a sense, we want to unlock parallelism for humanity. So you can imagine, you're single-threaded. There's no way to multitask. There's no way to delegate for a human, and that's why we have organizations, because we want to build organizations with 10, 100,000 people, so we can parallelize and do things. The idea over here is, can we use an agent to sort of parallelize and move from a single-threaded race, which we are essentially, to more of a parallelized race, where we can unlock async primitives for ourselves. And so we want to be able to just launch multiple agents and await them, and then be able to accomplish all our tasks. And this is what we sort of want to enable. Cool. And so this is what you're building. What we'll be doing for the hackathon is we'll be giving you control over your browser using our API. So you'll be able to, if you're logged into any service on your browser, you'll be able to control accesses using Multion and build an app. So you could build an app that could work from your phone, it could work from a service, anywhere. And so our API will allow you to connect to your browser and perform any service on your behalf automatically. And this is essentially, you can imagine it's like one general API, because we are using the browser as a universal interface. We can connect with any service, so it's basically one API to do them all. And I can show you an example. So we have set up this Python package that you can use for the hackathon. And yeah, so you can basically, so I'll show the instruction. Let me pause here for a bit. So what you can do is, for the hackathon, you can install a Python package from Poetry, from PyPy. So if you do pip install Multion, you can have that. First time you have to log in, so you log in, create an account with us. The next time you can just say multion.new session, and you can say give it a command, give it an input URL. So in this case, I said let's make a tweet announcing that the Multion API is live, and send this on Twitter, and yeah. And as soon as you press the button, so this opens Twitter. This is Multion controlling our browser, doing the actions, and that's that. And then you can see the message that Multion sent, whatever it did, using the output response. And then we have also set up a LangChain agent toolkit. So you can we have a LangChain example, so you can go and build agents on top using LangChain, or directly also using a Python package, where you can call our basic APIs. So if you want to integrate this with OpenAI functions, you can do that, and be able to use Multion as an action layer to do a lot of interesting things. And yeah, so we have this folder set up. So if you go to Multion/API examples, you'll be able to see a basic example on how to use LangChain, how to use our APIs, and integrate with it. And feel free to come to our help desk, so basically here, for any further things. And for the hackathon guidelines, yeah, sorry, there's a blank point. So you have to accept our participant agreement and a waiver to be in access. You're not liable for any wrong purchases you make, so that's on you. And anything we have a lot of fun with the Multion API. We'll be giving like free access for the hackathon, so you can do unlimited whatever you want. And we will be activating accounts at like 11:59 for the hackathon purposes. And there might be some rough edges, as this is like our first sort of like actual job. Cool. And should I end with the actual demo? Okay. Oh, sorry, yeah, we'll try to keep fast. So, okay, let me control my computer using my phone. So, let's see this first. So, okay, so I have an app, and I basically chat up. I said, like, okay, let's make a 100-word tweet about the agent hackathon at the AGA house on Twitter. And let's see if that works. Oh, no, OpenAI crashed.
I think the Wi-Fi's down.
Oh.
Try the latest two. Usually the latest Wi-Fi is not working. We have two separate lines.
Interesting. Let me try that again.
It's the same password.
Is this online?
Yes. Let's do one more try. No. Okay, I will just directly try to do it from my computer. So, okay, let's do this demo. So this is Multion, and it's working. It should be good. So let's try. That's just something like order. Let's order like lattes for everyone. So order 200 lattes from Starbucks. Using DoorDash. Yes, okay. Sounds good.
Can you get one with a shot?
So here it's like picking a plan on what to do, and you'll have to hope that the Wi-Fi works. Yeah, I'm not sure about the Wi-Fi. Let's see.
Well,
Let me just check my Google Docs. No.
it's a little slow.
Yeah.
Latest two. Try latest.
Let me try my. That's better. Yeah, sorry, still Wi-Fi. I guess you guys should upgrade your Wi-Fi. Let's see if I can get connected. Okay, might work. Alright, let's give it another try. Right, yeah, just did Okay, now it's working. So we need to go dash. And the agent is controlling the browser. And it's setting for Starbucks. Okay, let's see what it does. Okay, nice. Okay, went to Starbucks. Nice. Okay, cool. Nice. Okay, maybe I will get a latte.
Yeah,
Oh, well, that was easy.
It's a knife.
Yeah, you need to like suit to the size. Oh, is it actually doing this? I guess this could be a sponsor mine. And let me tell it to like choose a latte. So if I say choose the cafe latte. That's it. Okay, yeah, and it's probably have to like see if you do the whole thing.
Extra cream on mine.
And to God. Okay, I'll just Oh yes. Did we actually get this? Okay.
Thanks so much.
Yes.
All right, we have Switz, who's going to give us a lightning talk on small developer. Switz, can't you see him?
I hope this works. The Wi-Fi kept showing out it's not a good sign. Oh, yeah, cool.
Hi. Is this working? Yeah, I'm like not. I'll tell this story as one developer, but this is more about just learning. If the screen shows up. What do I do? Okay, cool. So I want to show you a agent I use 20 times a day. I think in terms of the development of agents, there's like one agent that you can use once every 20 days, or you can have agents that you use 20 times a day for much smaller things. So I have this little menu bar app that I always use that basically has ChatGPT, Bard, Bing, and Claude, and I can supersize it, and I can ask it like, what is love? So like it's a very minimal viable agent, right? Like each of these, it's the full app, so I can switch this to like to do research with web browsing mode. Bing can do research on its own. Claude can't do anything. But it's the kind of useful app that is small and it's very self-contained that you should be able to code up by yourself if you wanted to. The fact that it took me like I think a couple of days to make this actually slows me down. I think that the future of productivity with AI native sort of development is that you can develop at the speed of your thought. Why am I starting off with this? I think we're in a bit of an agent mania right now. I think Andre was cautioning people about this as well. I just like to remind people that in the 1600s, like we also bought tulips for like $500,000. Just because we thought that there was some very high potential there. Similar things happening with AutoGPT right now. I'm not saying there's zero use. I think there's a lot of research use. It's pretty much read only as far as I'm concerned. But you don't get this kind of trajectory on GitHub stars and have people tweeting about it saying I don't believe anyone uses it without some overhype there. So the core question I want to pose to people, I don't want people to be too cynical. Core question is how do we make useful agents? And that's what I would like everyone to focus on. I'm very inspired by Ben Thompson. He's been a tech writer for a long time. And essentially there's two schools of thought with AI. The Zuck school decides for you, and the Jobs school is a bicycle for the mind. And I think that's essentially what we're facing with autonomy and agents. There's a very strong parallel with the domain of self-driving, where there's a hierarchy of 6 levels of self-driving that they've already mapped out. And everyone's kind of racing towards full autonomy, level 5, level 4 autonomy, and getting credit for it, right? Getting credit for the vision. But in practice, I think we have to be practical and build our way up to there rather than jump right ahead. So the core bit of my inspiration, where I came in, because I've been watching this from the sidelines for a while, was taking the AJAX source code, which is understandable and in a single line GitHub file. By the way, the best way to understand any source code is to just chuck it into ChatGPT and ask it to plot a diagram, and it gave me back this diagram. I also asked it to highlight particular agent sections, and that was the initial loop of like what I thought an agent structure could be. I think the problem with this though is that it is basically designed to be autonomously run, and the way that most of us do this is we add interrupts. Like we just like, hey, human, do you want to proceed to the next step? It's not a very nice experience. We do want some level of autonomy. And I basically worked it up into this blog post, which you can read, called The Anatomy of Autonomy. I swear I didn't plan this, but yeah, like straight up it was inspired by the human brain as well. You can read more about that later. I basically moved from that sort of central premise into the design of small developer, and I don't have demo because I don't want to risk the internet shorting out. But essentially, I made my own Chrome extension using a prompt. The prompt started from a single small little paragraph, and then it moved to a markdown file.
And this is a trick I call Markdown is all you need, right? Markdown is the superior programming language, not English, because you can write code in prompts and prompts in code in prompts, and you can infinitely less, and it follows perfectly, really fine. I was also able to find a lot of other benefits like CSS animation. I could say what I wanted and it followed it, and I never had to learn CSS animation, which is great. But I think I'll skip to the tricky part. The tricky part is essentially the same problem that the Stable Diffusion people, text-to-image, text-to-video people have, which is coherence. How do you establish coherence for a whole app when you're doing multiple files and they all depend on each other? So my trick was to make it output an intermediate step called shared dependencies LMD. Sorry, there's a whole bunch of things. Yeah, I'll skip to the end. Shared dependencies on LMD returns like a list that, like a central manifest that all the other generations would depend on. But it was too primitive, and you needed to do a lot more verification steps. So I'll skip to the end. My plan for, I guess, the rewrite as a small developer is actually very inspired by Jim Phan's work on Voyager. I think one of the central insights of Voyager is that instead of trying to one-shot or rely on the LLM to always decide for you, you're constrained by the LLM doing that. Instead of that, you build up a skill library that you have validated and tested, and once you have written code that you know works, call that code rather than to keep calling back to the LLM. So there's this fundamental inversion that I've been feeling, that I expressed recently, that all of us are switching essentially from an LLM code shell architecture to a LLM shell code core architecture. And once you have code at the center of your architecture, you're much able to control it because it's very familiar. It's basically the standard components of our architecture with an intelligence layer on top. So I highly encourage people to explore these ideas. I'll be around most of the day to hack on that, and thank you.
So I just sent Success' essay out over this. Strongly recommend his take on agents. Bring it up. Amjad Saad's going to give us a bit on agents and Replit. David, or you?
Yep, just going to talk. I'm actually going to take exactly the opposite view of Swix. And I think it's overrated to think about something as useful or not. In fact, I think at the beginning of something new, it's probably better to think about mad science experiments to do. So throw away this concept of usefulness and make some crazy shit. Mad science is played a huge part in my career, at least. Even the start of Replit was, what if you could evaluate a lot of different languages in the browser? And we were the first to compile CPython to JavaScript, and then Ruby, and then a bunch of other languages, and that became a startup. All my career, even all the projects at Replit starts with what if. So think about what if just start with a question, what if? What are you really curious about? Some of the things I'm curious about is self-organizing agents. Now we have this, now we have these software components that can actually negotiate their contracts on the fly. So if you remember the agent model from programming languages like Smalltalk or Erlang, one of the limitations of it is that all the different agents have to actually understand all the different functions and functionalities of these components. But now they don't. They can actually patch themselves on the fly. They, especially with GPT's new function calling, they can call each other's functions. They can negotiate new contracts, and it becomes more like a living system. So imagine a cloud of agents kind of coming together to figure out what is the best goal. And hopefully that best goal is not to destroy the world. Speaking of destroying the world, the other day, I don't know if a lot of people know that, but Baby AGI was actually born in Replit. The author, who's a hobbyist coder, found Replit to be sort of a safe environment to do evaluations and run AI in a a sandbox environment. So what you can really do with that is, we give you a virtual machine in the cloud. You can read the files, you can write to files, you can evaluate, you can add dependencies. You can do all of that, and if the AI goes rogue, you just shut it down. And it's a really safe environment. The only thing you should worry about is your secrets. So especially OpenAI, sort of key, just make sure you have a spend limit. And honestly, you can do whatever you want with our cloud. You can abuse it. You can build self-replicating agents. I sort of quote tweeted the other day, Baby AGI, and it's when they were building like reflection and self-editing and self-replicating. And I said, you know, if Baby AGI self-replicates and take over Replit Cloud, if it happens, it happens. And it caused a freak out in the AI safety community. And actually, one of them was in DC and started lobbying against Replit being a substrate for agents. Obviously, I think all of this is kind of a toy. And honestly, we're so young as a field that there's like too much seriousness. And I think the best thing to do is to play and to figure out like what kind of projects you want to do. And we want Replit to be the substrate for that play. Don't run those those tricky agents on your computers or your cloud. Just run them on Replit. And we actually have a few ways of doing it. We have obviously the main sort of container you get when you start an environment. You can deploy a virtual machine in the cloud as well. And any of those things, if they get sort of pawned or like you don't care, you can just shut it down. We'll help you shut it down. Again, if you take over our cloud, we're okay with that, as long as like you're not doing it maliciously. We also have a new API, an extensions API, where you can extend the Replit IDE and runtime environment, and it gives you really nice APIs like writing files, execing, and do all that stuff. So you can really build these kind of concepts of like being able to self-improve and self-replicate and self-organize. And who knows, like maybe this is like a birth of sort of a new Zudo life. And I'm really excited to see some of these things. And I think, in fact, counterintuitively, the best way to build startups is to actually start with play. Is to start with like just exploring the sort of design space of agents. And the best way to do that is really brainstorm radical ideas. If you want to play with Replit, we're around the kitchen. We can give you some credits to do deployments or evaluations or whatever. So thank you.
Okay, we have Jim Fan. Adam D'Angelo, you're around to make your way to the front.
Hi everyone, I'm Jim. Many of you may know me as Dr. Jim Fan on Twitter. I am a senior research scientist at NVIDIA, and previously I did my PhD at Stanford. And I used to be Andre and Tim's intern at OpenAI like 7 years ago. We worked on Open Universe and World of Bits, and that was one of the first software agents. Very fun memories, and today I want to share a little bit on generalist agents on open-ended worlds. So what environment is more open-ended than Minecraft, right? Minecraft has got 140 million active players. And just to put this number in perspective, that is twice the population of UK, and 5 times the number of programmers worldwide. So it just so happens that gamers are generally happier than PhDs. So they love to share what they're doing on Minecraft online. And that means 2 things. One is there are lots and lots of YouTube videos that gamers upload. And second, there are lots and lots of Minecraft texts and tutorials for GPT-4 to train on. And today, I want to discuss a little bit on these ideas. So last year, I led the team to build a framework called MindDojo, which is an open source framework to help the community develop generally capable agents using Minecraft as a kind of primordial soup. And I will share 2 ideas today enabled by Minecraft, but are generally applicable to many other domains. So the first idea is about the massive amount of videos capturing human strategies and creativity. So we scraped in MindDojo 300,000 YouTube videos with 2 billion words in the transcript. Like these are actually the real transcript and video snippet from one of the most popular YouTube tutorial videos on Minecraft. And what we can do is we can learn the association between the video and the transcript that describes the action of the video. So this score goes from 0 to 1. And intuitively, 1 means perfectly aligned. That means the text describes the action in the video. And 0 means the text is irrelevant to the video. So what does that mean? This looks like a reward function, right? And then we can plug in this model called MindClip, which is a reward function, into action. So here, as an example, our agent is interacting with the Minecraft simulator. And the task here in natural language is shear sheep to obtain wool. And as the agent explores, it has a moving window of the video snippet. And you can compute this score. from this reward function, and you provide that to any reinforcement learning algorithm. So what does this look like? This is RLHF, RLHF in Minecraft, reinforcement learning from human feedback. And RLHF is the cornerstone algorithm that made ChatGPT possible, and I believe it will also be the cornerstone for building journalist agents as well. So these are some of the videos from trained by RLHF in Minecraft. And you can see that many of these tasks are relatively short horizon, about 100 to 500 steps. And that is because the reward function is only able to capture a short horizon. So back last year, the goal of having an agent that explores and makes new discoveries autonomously seems out of reach. Until, thanks to Andre and his team, GPT-4 came, a language model that's so good at coding and long horizon planning. So correspondingly, we built Voyager, the first large language model powered lifelong learning agent that plays Minecraft for hours on end. And thanks, Sean, for already covering a little bit, so I will quickly gloss over this. So the video here shows snippets from not just multiple episodes, but a single episode of Voyager, and it just keeps going, right? It's always traveling to uncharted territories and finding new things to do by itself, and picking up new fights and solving new challenges, all without human annotations. So how do we do this, right? We want to use the full power of GPT-4. That means we need to stringify things. And the way we do it in this multimodal environment, Minecraft, is to use this open source framework called MindFlayer, which is a high-level JavaScript API that essentially converts the observation, the pixels, and parses it into text. And then we also take actions as code in text. So this is one example of writing a JavaScript function to attack an enemy using the MindFlayer API. And that will execute in Minecraft. So the key idea of Voyager is to use code to control an embodied agent. And because GPT-4 shows a quantum leap in coding skills, and that's what made Voyager possible. And also JavaScript runs a code interpreter. That means Voyager can actually define new functions on the fly and run it interactively. But the code that GPT-4 wrote may not be correct on the first try, so we developed an iterative prompting mechanism where there are 3 types of feedback. One is the execution error from JavaScript interpreter, if you make a syntax error, for example. And the other is environment feedback, like you get a piece of item after executing this action. And another is a critic, again instantiated by a separate GPT-4 that does self-reflection from the agent's own past and its own state. And these help the agent refine the program effectively. And then once it implements a skill correctly, we will save it to a persistent skill library. So you can think of it as a code base that's authored purely by GPT-4 through trial and error. And the agent can retrieve skills once facing similar situations in the future, so it doesn't have to implement and try the skills and debug the skills again. And in this way, Voyager improves itself as it experiments more and more in Minecraft. So this is finally, the final piece is automatic curriculum, where we give it an unsupervised objective of just discovering as many items as possible, and then it automatically discovers that these are the things it needs to do in sequence. And putting all these together, we have an iterative prompting mechanism that's essentially in-context reinforcement learning through trial and error, and then we have an in-context skill library or replay buffer, and we have an in-context way to do exploration. So overall, this is Voyager's no gradient architecture, where we don't train any new models, we don't do any gradient descent, and Voyager can self-bootstrap and perform lifelong learning in an open-ended world. So please visit our website. I'll just quickly go over this. Some superior performance compared to the baselines, and we see that Voyager is a great traveler, and that's the name. It travels way more than the baselines methods. And check out our website. So this is minddojo.org. That's our work from last year, and we got New York's best paper for this work. And voyager.minddojo.org, where we open source everything, also including the pre-trained skill, the pre-trained quote-unquote skill library that Voyager generates. It's on our GitHub. We also have the MindClip model, that's the foundation reward model, open source as well. And finally, if you want an excuse to play Minecraft at work, this is your perfect excuse. You're doing it for science, you're collecting data for MindDojo. Just one last thing, I want to remind all of us that despite all of these progress in agents, we're still really far from what humans can do in Minecraft, right? Like these are videos of humans implementing a working CPU inside Minecraft, because you can use redstone circuits, and apparently the game is Turing complete. But of course, it's way beyond the capability of Voyager right now. So let's see if Voyager 2 or GPT-5 with some no-gradient architecture can finally solve these grand challenges. And finally, life is short, so let's do some hardcore AI research and have fun at the same time. And I'm Jim. Thanks for having me.
To anyone building agent at our hackathon, I strongly recommend the Voyager architecture, the concept of the skill library, and plausibly Jim's tools. So briefly, we talked about potentially having an open source version of Voyager that could acquire whatever skill library was relevant to the context of an agent's use, and maybe one of you actually may pick that idea up and run with it.
Thanks.
Right. So we have Adam and Angela. Quick one.
Hey everyone. So, just as quick background, I'm a founder and CEO of Quora, and most of Quora's energy right now is going to Poe, which is a new AI chat product that we've been focused on. So, I wanted to just start out and talk about why I'm excited about agents personally. And this is partly my perspective as an engineer, but it's also my perspective as an investor. So, if you look at many of the great technology companies that have been built over the last few decades, there's this pattern where they're almost always riding some kind of technology wave that makes something new possible. And there's usually this feature of the technology waves that not only makes this new thing possible, but makes it difficult for the existing companies to adapt to it. So, to give you a quick example, Microsoft in the 80s and 90s, they recognized that the PC was going to enable computer access for everyone. And because of that, they were able to seize the opportunity to create DOS, and then later, as the PC got more powerful, create Windows. And that was really only possible because of this new wave that existed. Later, if you look at the internet wave, Jeff Bezos saw the opportunity for Amazon and just what was going to be enabled with e-commerce through the internet, and he was able to jump on that opportunity and get there really before any of the established companies had gotten there, and then establish a strong position. And later on, as broadband got more widely deployed, suddenly video streaming became powerful. And you'll notice that Netflix was a company that was kind of created as a result of that wave. But I think a very interesting thing about Netflix is that they started before internet bandwidth was actually good enough, and they, as a result of that, they had to start with this DVD by mail service. But it was because they could see that this internet bandwidth was coming, and so this is one reason you'll notice the company was called Netflix, even when it was still a DVD by mail service. So I think in all these cases, you have an entrepreneur saw that because of this technology wave, there was going to be this potential for these huge new markets, and kind of got ahead of everyone else. And then also the existing companies just had difficulty adapting to the wave, which was what provided this big opportunity. So I personally think agents have fit this pattern really, really well, and possibly even better than some of the previous technology waves. So there's this incredible increase in GPU compute that's becoming available to everyone. Obviously, we all know that. I think the first wave of this that we saw is in these chat products, which are getting very widely deployed and very popular today. But similarly to how Netflix was kind of this second generation of internet opportunities, as bandwidth got more and more powerful, I think agents are going to be the kind of second wave of AI products that become possible as GPU power gets more and more widely deployed and accessible to everyone. And I think there's these big barriers to adoption for existing companies that are both going to make it difficult to create agents, and so there's probably a lot of what I think everyone is struggling with today in terms of getting agents to actually work and be practical. That's actually a very good thing in some ways, because it's what makes it hard for these existing companies to invest in them. So if you heard Andre's talk, like I think one of the reasons why OpenAI may be not as on top of progress in agents, it may be that there's just it's harder to build a good consumer product with these today. But I think that's obviously, I think we're all here because we think that's going to change. I also think the fact that agents are going to be so powerful and able to do things, that's going to mean that sometimes there are problems created. There's going to be things are going to go wrong. You might get the wrong DoorDash order to your house. You might also, but I think there's a lot of other safety risks that become real as agents continue. And that's going to make it hard for existing companies to adapt. And so as a new company, you'll be able to take this risk in a different way than existing companies are able to. Last I just wanted to mention, in case it's useful to anyone, for Poe, this product that we've been building, we have millions of users and we have an API now. So if what you're building is appropriate for a chat interface, we have a very simple way for you to hook that up, and we'll get you can get native UI across iOS, Android, desktop, web. And if you're interested, I'm happy to share more details on that. If you do get to the point where you have an agent that is ready for production and ready for consumer usage, we'd be very happy to talk to you about, one, giving you distribution to our users, and two, covering your compute costs as part of that. We have a lot of revenue coming from users already, and we'd be happy to share that with everyone. So I think there's some really exciting opportunities available for everyone here, and I'm really excited to see what you all do. Thank you.
Okay, so we have Jerry Liu from Llama Index, who's building an incredible way for us to connect the tremendous amount of data our agents need to our agents. Yes. And Matan, you're on deck.
Sweet. Hey guys, my name is Jerry, co-founder and CEO of Llama Index, and today I have 5 minutes, so this is just agents for data retrieval and analysis. Whether or not you use Llama Index, this is just some practical guides that we've discovered while playing around with the OpenAI function API. And so yeah, this is specifically using the OpenAI function API. Most of you have already seen this. It's super cool, and honestly, it there's some emergent properties that you can just use to do advanced data analysis and retrieval over your different data sources. Brief background on Llama Index: it's like a data framework to do data management and querying on top of your data if you're building an LLM app. I'm going to skip this part. Let's talk about the OpenAI function API. So it came out a few weeks ago. It allows you to specify functions in the completion endpoint, right? And so what does this mean? This allows you to basically specify a set of function signatures, and then it can actually reason about whether or not it wants to call a function or actually output a user message. And so the implication here, beyond just the fact that the outputs are structured, is that you can extract structured data, but also more easily build different types of expressive agents over your data. So I'll link these slides in the Slack channel, but to build a basic agent, the agent loop gets a lot simpler because you can basically just do a while loop on top of the OpenAI function API that checks if the function call is specified. And so we have a quick guide to show you how to do that. And regardless of what agent you pick, you could build your own agent, you could use LangChain. We have a very simple implementation as well. The next step is, okay, now how do you plug in data tools into this agent loop so that it can perform different types of data tasks? And so if you have a tool that's for instance, that does semantic search and retrieval augmented generation, you have another tool that does summarization of your data. You can have another tool that does text to SQL or structured analytics, or another tool that does document comparisons, right? And if we think about the tool interface, the very simple interface is you just pass in a string. And so the API interface is just like very simple for the agent to access, and all it has to specify is like a string parameter to the agent for it to kind of like act upon, for it to execute the tool, and then the tool can go and like actually do these things over your data. But like beyond kind of like simple API interfaces, or the next step I was going to talk about is because this agent loop can kind of like do sequential reasoning out of the box, like by passing in a single call to the API, you can reason about the next step. You can actually get some pretty advanced like data analysis capabilities out of the box. And so, for instance, one of these is this idea of like auto retrieval from vector databases. I think in LangChain it's called like self-querying. But basically it's like the idea of inferring retrieval parameters like metadata filters before you actually query a vector database. And so you could construct like kind of your own system to actually call the LLM to infer that, or you could actually just pass it to the function API, and then the function API can directly infer these function parameters that you then want to pass in to the vector database. The other is if you have like both a structured analytics tool as well as an unstructured analytics tool, like one is vector databases, one is structured data, they can basically, the agent itself can out of the box reason about complex interactions over your structured and unstructured data. And then last bit, this is like a lot more exploratory, is like the function API can infer structured outputs, right? So not just strings, but also just like arbitrarily complex pedantic objects. If you guys follow one of my friends like Jason on Twitter, he's been like super active about this. Check out his repo, it's awesome. But basically like you can treat these pedantic objects, like it's not just like for its own sake for structured data extraction. You can actually treat it as like a query plan or DAG over your data. And then if you actually execute this DAG over a set of like subtools, then you can basically get kind of query planning agents with the function API. Because the function API will infer like a query plan from your pedantic objects, and then you can execute this query plan over your data. And so it's pretty cool. And then we're still kind of like figuring out the best practices for that. But if you guys do try it out, I'd be very interested in seeing kind of what the results are. Sweet. And then the last bit is if your set of functions is too large, this is just a very practical tip. You can try like indexing the set of function signatures, doing retrieval on top of the function signatures, and then feeding it into the function API. That's it. Cool.
Okay. So Giphy Matan was a state-of-the-art agent which will help you modify and improve your code base.
Hi everyone, I'm Matan Grinberg, co-founder and CEO of Factory. First of all, I want to say thank you, organizers, for setting this up. Actually, Factory has its roots at the LangChain hackathon that was held here, so that's pretty exciting. But yeah, so Factory, what are we doing? So our vision of the future is one where software systems work on your code base like a real engineer. So not one extremely narrow application, but across the stack. These systems will understand your code base the way a human does. They'll provide production-ready code with minimal supervision, interpreting what to do through functional requirements and context. These will integrate with existing engineering organizations and compound their productivity by orders of magnitude. There's kind of a lot of notes here, but I know we're rushed on time, so. What this entails, so in particular, code-based understanding beyond just semantic search built on a vector database, that kind of allows for this next step in terms of software engineering agents. And so that's what we're building. It's very ambitious, but it's very fun. So what does this look like? So you connect your tools to this software system, which we're calling Droid. Lucasfilm might get upset about that, but it's okay. And so what actually is inside the Droid? Well, we have what we call a reflection system, something that we're calling ByteRank, and yes, we trademarked it, and something that we're calling the Polymath engine. And so I'll talk a little bit about these. So in particular, ByteRank and our reflection system basically ingest the information in your code base. If you want to deploy this in production-ready systems, you'll have to be ready to deal with millions and millions of lines of code. Very unstructured, very unorganized, because again, not everyone has the greatest code base. And so to that end, we have a reflection system which handles the ingestion, uses LLMs to synthesize information that a simple vector database won't have. And then we have ByteRank, which basically allows us to go beyond the just top 5 relevant semantic search results and then throwing that into the context window. And again, there's a lot of details here that I'm very clearly glossing over. I'd love to talk more in depth after this. And then, so also we have the polymath engine. So there are many tasks, as we all know, that engineers do, and they all have very different silhouettes. So like debugging looks very different than starting a project from scratch, which looks very different from writing unit tests. And at least as of now, my understanding is that these LLMs aren't good enough to generically accomplish all of these tasks, at least in terms of like one generic agent architecture. And so to account for that, we have this engine which tailors each architecture to each of these types of tasks. And then lastly, we have what we're calling Crucible, which is our evaluation suite. I would be really happy if anyone here knows how to solve evaluation. I don't think anyone does. So that's what we're working on, because ultimately, the space of agent architectures is enormous, and it's really hard to say, hey, this agent architecture is X% better than this other architecture. And so that's what we're building up with Crucible. Lastly, we are hiring. I think this is honestly the best audience for people we want to work with. So email me or talk to me, and yeah, thank you guys so much.
Great. So Rocky is going to give us a short bit on that.
Yes. Hi everyone, I'm Rocky from this AGI house. Thanks to actually a lot of people, Andre and Jeremy built this last year, and this year took over and have the mission. We want to help facilitate humanity transition to AGI. So how we do it? So we have people like Andre that do the frontier research and then really push that side of things. And the other side of things is people like us here doing the hackathons, really building the tools, putting all these powerful models in every single humanity's hand. I think that's what we're doing, and what we want to see, what you guys building today. Very excited. Some house rules. So the second floor of the house is for residents, so don't go to those rooms. Those are private rooms, and anyone else see private room, do not enter. So please don't enter. Anyone else, feel free to roam around, find your place, find your spots, and do whatever you feel comfortable to hack. And then we have the drinks by the kitchen, that area, with the waters, the sparkling water, and the food, and the lunch will come around right now at 1:30. And dinner is served at 6. And before that, I think this thing we won't have it without our sponsors. We have our sponsors here. So what's first? CRE, Divya, and Frank. The Wi-Fi. So on the wall you see latent space. So that's the Wi-Fi generating works. So we have another second line because to solve this Wi-Fi congestion. Because latency 2 is for maybe for demo. It's also the same gigabyte line, the same password.
Hi everyone, we're so excited to be hosting this event in conjunction with AGI House. Just to introduce ourselves a little bit, Brittany and I are both part of a firm called CRV. We've been around for 50 years, hopefully you've heard of us, just raised Fund 19. We're earliest partners to companies like Vercel, Airtable, DoorDash, many, many others, and InWorld, who's also here sponsoring the event and co-hosting with us today. We're so excited about, as everyone has talked numerously in length about what agents can mean for AI. And while we understand there are a ton of limitations, we know that the next large companies in this wave could possibly be born here today, and by the people hacking away at this hackathon. If you guys ever want to jam on anything AI related, Brittany and I are spending all of our time in this space. We're always happy to lend a ear on whether or not what might make a great idea, what might make a great company. You can reach us anytime. Our emails, our first names, Vivian and Brittany at crv.com. But thanks again to AGI House for co-sponsoring with us, and again, excited to see what projects come out today.
Thank you. Hey guys, excited to co-sponsor this with CRV and everyone else. Thanks to Div for pulling us in here, shout out. And thanks to Jeremy and Rocky for organizing this. We're ABC. We're a fairly large venture fund at this point. The core thesis when we started the fund was to go take legacy verticals and disrupt them with data and automation. And the natural extension of that is you have all these vertical SaaS companies that can be augmented by agents and foundation models, and seeing how we can apply them again. Historically, like, that was our thesis, and something that I'm seeing a lot of our CEOs say across both vertical and departmental software is like, how can we incorporate agents? How can we do better automation? Like, Ram over there is working on clinical trials. He's trying to figure out how to automate some of these legacy workflows. And across so many different industries, we have like a freight billing company that's figuring out how to do agent-based automation, or a insurance claims adjudication company. And a lot of the issues with applying agents to these settings come back to what Andre was saying earlier around like reliability. And something that people are thinking about is like, how can you coerce the control flows or reasoning traces into something that's more reliable? I'm curious how a lot of you think about these problems and how you think about evaluating agents. But yeah, I have two of my fantastic colleagues over there, Bella and Kevin. You should feel free to find us if you want to work on cool applications and enterprise software for agents, and feel free to reach out to us at ABC anytime. Cool. Thanks, Dave.
Hey everyone, I'm Sophia. I lead a product management for AI at InWorld. We are a developer platform for AI-driven characters, NPCs, for immersive experiences. So if you're interested, go to inworld.ai. You can pretty much go in, and we already have speech detection, emotion detection, intent detection, knowledge, memory. A lot of the services are already pre-built for you. So when you're building out your agents, pretty much all of that is good to go. We also have voices, gestures, animations. We partner with AAA studios, indie developers, and also a lot of web-based applications as well. If you are interested, we actually just had a game that launched called Origins, where it's a murder mystery game, and you go in and talk to the various players and characters and figure out what is going on. So that's just one of the applications, but we'll be right here. Myself, Matt Kim, our technical creative director, and Sherry Ali for PM integrations, and super excited about what you're building.
Amazing. Before we let you go, we want to recognize our resident here. Who's here? Dana, Paul, and Josh. Tim is here, and Jeremy, and me. Who else? Well, before I let it go to Paul, I have a few words to say. Are you building some cool agents?
I'm actually tired of standing up already, but I'm not sure how about you guys. But one thing I think we don't do enough here is we don't talk about you, and I'm wondering who actually you are, and like where you're coming from. Can I ask you a few questions about like where you live and like did you graduate from college, or did you are founders or engineers? Yeah. Sounds good. Okay. Can you raise your hand if you're a founder? All right. Half the room. Who works for a big tech company? Okay. Who has a startup that raised money this year? Okay. Interesting. Who lives in San Francisco? Nice. And who is out of state? Okay, cool. Who is out of the country? Who is like from? Wow. Wow. It's pretty cool, right? Who is from Asia? Nice. And Western Europe? Nice. Eastern Europe, maybe. Wow, 3 people. Amazing. Who has published a research paper in your life? Who has published more than 5 research papers? Keep your hand raised if you publish more than 10 papers. Okay, 1, 2, 3. Who has published more than 15 papers? Okay, Jim, let's give a round of applause for Jim. Okay, so who has raised more than 1 million in your career? Okay. Who has raised more than 5? Okay. More than 10? 50? 100? 200? 300? Okay, Josh, where are you like at 200 to 300? Okay, so Josh, raise your hand. So let's give a round of applause for Josh. Wow, it's a pretty cool crowd, right? So what else can we ask? Maybe like, yeah, final question. How many hackathons you did this year? Let's raise your hand if you did at least one hackathon this year. Okay, cool. 2, 3, 4, 5, 6. Good, Jeremy. Who else? Anybody else? Oh, 7. Wow, Jeremy. Let's give a round of applause for Jeremy. All right, this is just a quick community kind of building exercise. Thank you so much. My name is Paul. I live here. Build a company as well. Please reach out if you have any questions. Thank you.
Okay, it is time for the mic to go to you. So if you have a phenomenal idea for an agent, do come forward. Let's actually gather a line along the street, so if you're here to make space. And we're basically be giving 1-minute lightning pitches for your hackathon idea. So even if you've just had a creative idea, just stumbled upon something, do come forward, and the people in the crowd will hear your voice, will make sure that they can find you in Slack, and you'll build your team up. I sent out a spreadsheet, so if you sign up in that spreadsheet, you will be first. So the first is Eduardo Gonzalez.